Now that we've understood a little bit about the nature of fixed points and flows near fixed points, we want to enlarge our understanding by looking at what happens to fixed points when we change some parameter in our equations of motion such that the number of fixed points changes or the fixed points move around in the state space. And this brings us to the topic of bifurcations of fixed points. So we want to understand changes in the global flow when some parameter in the equation of motion changes. Let me illustrate this with a really simple example. Let's suppose that we have some arbitrary nonlinear function f of x. Here as a function of x, this is x dot equals f of x. And let's suppose, for the fun of it, that our function is just some multiple humped function. And let's suppose, furthermore, that there is some parameter in f of x that just changes the height of the function rigidly up or down. And let's ask what happens as we move our function f of x up or down. So for this particular choice of this external parameter, so let's imagine that in this function f of x, there's some parameter h which just changes the overall height of the function. So in this first example, we know there's a stable fixed point here and an unstable fixed point here. So there are two fixed points. So let's imagine now that we lower the function a little bit, and if we lower the function just rigidly, so we do something maybe that looks like this, and now we see the stable fixed point to the right is still there, but two new fixed points have emerged where this middle dip in f of x crosses the x-axis. And so there's an unstable fixed point, and then a stable fixed point, and then another unstable fixed point. So we have four fixed points. And then if we lower the function still further, we may lose the fixed points here, but just retain the two fixed points on the right-hand hump. And so we get one stable and one unstable fixed points. We go back to two fixed points. And finally, if we lower the function still further, we have no fixed points. So this is the thing that we will want to try and understand in a more systematic way. As we take some arbitrary nonlinear function f of x, we have some control parameter in the function that moves the function around such that fixed points are created or destroyed. We want to understand that quantitatively because this will be the basic ingredient to understand the rich phenomenology of nonlinear dynamical systems.